Hello, my name is Jeremy Little, and in today's expert session, we'll be talking about ThingWorx backup and recovery. To start, we'll go over some backup terminology. We'll talk about disaster recovery. We'll talk about what's involved with backing up ThingWorx, and then we'll go into some detail about specific recovery strategies for the different databases that ThingWorx supports. First, some terminology. A physical backup is a byte-for-byte copy of a file taken from one machine and stored on another. Having multiple copies of data stored in multiple locations provides redundancy, which is a key factor in backups. A good backup strategy will maintain multiple physical backups at all times. A local backup on separate hardware will provide for a quick restore. Prior backups should be kept for a reasonable amount of time in case the most recent backup is corrupted. Finally, every backup strategy should have at least one offsite backup location. These days, cloud storage provides a convenient and often cost-effective means of backing up your data offsite. A common saying that is tossed around when it comes to backups is if you don't have your data in at least 3 locations, you don't have your data. This statement stresses the point that a hardware failure is not your only worry. A full facility failure can result in the loss of your data as well as all your backups. So having an offsite backup is an important strategy when setting up a backup strategy. A logical backup is different from a physical backup in that it doesn't store the actual data that you want to keep. Instead, it stores all the information that is required to recreate the data stored in an environment. In order to restore a logical backup, the application must be set up again in the recovery environment. However, a logical backup is generally slow. All the computations that have gone into creating the data need to be done again. If you have a year's worth of data backed up using a logical backup, it could very well take a few weeks to recreate all that data from scratch. Some examples of logical backups: you have SQL dump scripts from your database, ThingWorx entity and data exports, and PostgreSQL write-ahead logs are all examples of logical backups. A cold backup is a backup that has to be performed with the server offline. This type of backup is required when the data consistency cannot be guaranteed while the application is running. In the case of a cold backup, the backup files are always guaranteed to be consistent because there were no transactions going on while the backup was being taken. However, there are a number of downsides to a cold backup. First of all, the server must be shut down while the backup is running. This means your users cannot use the application while a backup is being taken. As a result, a cold backup process has to be scheduled during a maintenance window, typically occurring during low usage periods. As the database gets larger in size, a longer maintenance window will be required to perform the full backup. A hot backup, on the other hand, is a backup that can be performed while the server is actively processing requests from the users. As the server is up and running, there is no downtime required to take a backup, and you can also take more frequent backups. Some of the disadvantages: a hot backup strategy can be difficult to set up and maintain. Not all applications provide a hot backup option. A backup process may impact system performance while it's running. Where possible, a hot backup is generally the preferred method of backing up your data. Disaster recovery. Some of the common failures that you'll encounter are hardware failure, where a physical device stops working, such as a hard drive, a server component, a disk and a storage array network. Data corruption, where invalid data is written over existing valid data due to a misconfiguration, a bug in the software, or something along those lines. User error, where data is modified or deleted due to an error in an issued command from a user. Malicious actors, where an external party destroys or corrupts data, such as ransomware or a targeted attack. Or a disaster such as a flood, fire, power surge, cooling failure, something that affects the entire data center. A responsible company will have established and validated their backup and recovery processes, ensuring that they can get their critical systems back up and running as fast as possible after a disaster. A key point here is having a validated backup strategy. If you don't test your backup strategy, can you be certain that you can recover your critical systems in the event of a disaster? So how does one go about defining a backup strategy? Backup strategy aims to ensure that when a disaster occurs, you can quickly return to a recent known good state with a minimal loss of work. When coming up with a backup strategy, there are a number of factors to consider. You need to consider what needs to be backed up, how much data needs to be backed up, can the backup be done online using a hot backup process, or is a maintenance window required because the system requires a cold backup? How intensive is the backup process? Where will the backups be stored? Are they going to be stored in the cloud? Are they going to be stored on external hardware? How much lost work is acceptable if a failure does occur? Generally, we're not talking about the massive natural disaster type failures where the entire data center is lost, but it's always good to keep that in mind. Like any other process and technology, backup strategies are a balance of trade-offs. More frequent backups will reduce the lost work, but they may negatively impact application performance or the uptime if the application does not support hot backups. In addition, there is a monetary cost for hardware, cloud storage, that increases based on the amount of data that needs to be backed up. The most important part of implementing a backup strategy is to test it before you trust it. This means you've taken all your backup files, you've copied them over to another machine, and you've brought that server up as if it were a restore of your existing system. A successful backup and recovery strategy will be fully documented and regularly validated by running sample recovery scenarios on a regular basis. Properly documented solution means that anybody who's available when a disaster occurs can follow the instructions to get the server back up again. In many cases, though, IT departments will aim to make the restoration as low touch as possible, often only requiring some scripts to be run to restore the system to a working state. Validation confirms that the documentation is accurate, the recovery scripts, if they're being used, are functional, and that the end result is a fully operational, recovered application. So how do we go about backing up ThingWorx? To be able to recover from a catastrophic failure, there are a number of components in ThingWorx that need to be backed up regularly. The Tomcat installation folder and configuration files, any SSL certificates and key stores. This is optional because SSL certificates can often be easily regenerated, but sometimes the signing process can take some time, especially if you're using an external certificate authority. You'll need to back up the ThingWorx configuration and file system data, any application-specific files or libraries that are used by your application on ThingWorx, and then finally the ThingWorx database. First, backing up Tomcat. Tomcat is the application server that ThingWorx runs on, and it's probably the easiest component to back up. Backing up Tomcat can be done either online or offline, it doesn't really matter. The backup process involves just taking a full copy of the Tomcat installation folder. This copies all the configuration files, any custom jar files you've deployed, and all the deployed web apps so that you can restore the Tomcat server to full working order. It is worth noting that each web app hosted by the Tomcat server may also have its own backup requirements due to external dependencies. ThingWorx is one of these applications that depends on files elsewhere on the system. Tomcat backups should be performed anytime the configuration changes. There really is no significant benefit gained from higher frequency backups, aside from the fact that you will have an extra backup in the event that your most recent backup is corrupt. However, if you're validating your backups, this shouldn't be a problem. You do want to watch out for dependencies on files outside the Tomcat directory, and you will need to know what files your applications will access. As an example, if you have SSL configured on your Tomcat server, you can store the key store anywhere. It doesn't have to be in the Tomcat folder structure. These files should be backed up as part of the Tomcat backup process. As I mentioned before, ThingWorx does have a number of file system dependencies. Specifically, the ThingWorx platform, the ThingWorx storage, and ThingWorx backup storage directories are external storage locations where files are stored. The ThingWorx platform directory contains configuration information such as your database credentials and server preferences. The ThingWorx storage directory is a big one. When you're using one of the embedded databases like H2 or Neo4J, this folder contains the actual database files. It also contains copies of your installed extensions, all your data exports, files that are stored in your file repositories, along with other configuration files as well. The ThingWorx backup storage directory only really needs to be backed up if you are using H2 or Neo4j. Postgres does not use this directory, but if you are using one of the embedded databases, it is worth backing up and having a copy of these in the event that your database does get corrupted. File system snapshots. Some of the newer file systems these days provide the ability to take a snapshot of a full disk in a matter of seconds. This allows for a copy of the disk to be taken from that time the snapshot was taken, while not impacting performance significantly. Your application can continue running on the front end while you're taking a backup on the back end. For the embedded database versions of ThingWorx, a file system snapshot can be used as part of a backup strategy as long as the snapshot is consistent down to the millisecond. The drive contents at the time of the snapshot should still be copied off the server as a secondary backup. For PostgreSQL backed versions of ThingWorx, file system snapshots may still be usable, but they should be validated in conjunction with the database backup first. The file system snapshot would need to be taken around the same time as database backup, within milliseconds. Database backup and restore. ThingWorx provides a logical backup mechanism through its export functionality. The import and export functionality do not provide a true backup in that a ThingWorx server can only be restored to an identical state if the database is emptied prior to the import. An import only performs create and update actions. It will not delete any entities or data from the server that is not present in the backup files. Rather than a backup strategy, import-export functionality is more frequently used for solution migration. Entity export is useful when migrating updated entities between a development and a production server. And a full entity and data export is used when migrating ThingWorx between database platforms. This generally only needs to be done when moving between Neo4j or H2 to PostgreSQL. For simple implementations, it's still possible to use a ThingWorx export as a backup strategy. There are 3 requirements when using ThingWorx export as part of a backup strategy. First of all, you have to back up your extensions. Most entities are often created using Thing templates provided by extensions, and these extensions must be present on a server prior to being able to import those entities. A repository of all the extensions must be backed up along with all the exported entities. The ThingWorx content is actually stored in 2 different exports. First is your entity export. This generates an XML or binary file containing all of the entities that you've selected for export. This is just a skeleton of the solution. It does not contain any of the actual data on the system. Data exports will write out your property values, your stream values, and your data tables into a format that can be imported at a later date. This export is performed exclusively to a file repository on the ThingWorx file system. Once it has been exported, you can still download it using the file system download functionality. There are some things to watch out for when you are using exports and imports in general, not just as a backup strategy. First of all, when you are doing XML entity exports, the Java file encoding flag must be set to UTF-8 on Tomcat's JVM. The reason for this is that by default, Linux and Windows use ASCII-based character sets. If you do not have this flag set before you do an XML export, it can cause your non-ASCII characters such as accented characters, non-Latin characters, to be exported as question marks, which will result in corrupted data when you're re-importing it. All the characters that were represented by question marks are now question marks in your database. Because localization tables are a prime spot for non-ASCII characters, especially with some of the non-Latin languages, this will seriously impact your localization information. For more information about setting this flag, see KCS Article 224103, available from the PTC support community. Another thing to be aware of is that exports only contain the data that is stored within ThingWorx. It does not include any data that might be stored externally, such as files and file repositories, any of your configuration data, stuff like that. Finally, relying on export-import is not a good backup strategy. It can work as a fail-safe option for restoring the core solution that was developed on ThingWorx, but it doesn't account for external dependencies. Backing up the Neo4j database. Neo4j was the first embedded database included with ThingWorx. As of ThingWorx 7.2, Neo4j releases are now considered deprecated in favor of the new H2 releases. Neo4j does not provide any hot backup options. For a proper consistent backup, the ThingWorx server must be shut down. Even though a hot backup is not officially supported, the scheduled system backup thing will run a nightly backup of the Neo4j database. However, it is not guaranteed to generate a consistent backup every night. In many cases, the backup will work, but we have seen cases where an automated backup is unusable due to a database transaction that was running at the time of the copy. For a proper backup, a regular maintenance window should be scheduled where the proper cold backup process can be followed. To do a proper cold backup with Neo4j, you want to shut down the Tomcat server completely. You want to avoid using a kill command because that can sometimes terminate transactions that are in the process of being written out to disk. If the Tomcat server is not shut down cleanly, pending transactions may not be connected to disk properly, potentially introducing corruption into your database. Once the Tomcat server is shut down, you can copy the full contents of the ThingWorx storage/database directory to a backup location, and when that's done, you can start the Tomcat server. To restore a Neo4j database, you would shut down the Tomcat server if it was running. You would want to make a temporary backup of the full contents of the ThingWorx storage database folder, just in case, and then remove the contents of that folder. You would restore the contents of the desired backup to your ThingWorx storage database folder. And as a good practice, it's always a good idea to rename the Catalina out and application log files so that any database errors on startup are easy to spot. If there is a problem with the restored data, it will be written out to application log. If the database itself cannot start, that will be written out to Catalina out. Once you've restored the files, you can start the Tomcat server and check for errors. The H2 database. The H2 database is a new embedded database provided with ThingWorx 7.2 and above. The H2 data files are stored in the ThingWorx storage/database directory, much like Neo4j, and like Neo4j, H2 does not support hot backups. As an embedded database solution, a scheduled system backup entity is created, which also copies the H2 data files to the ThingWorx backup storage directory on a daily basis. Similar to Neo4j, in many cases the backups will work. However, a transaction that is not committed during a backup may introduce corruption into the copy database. As a result, proper called backups should still be taken on a regular basis to ensure that consistent backup is always available. Doing a cold backup on H2 is very much the same as backing up Neo4J. You want to shut down the Tomcat server, you want to copy the full contents of the database directory to a backup location, and then you can restart the server. You want to shut down the Tomcat server if it's running, make a temporary backup of the full contents of the ThingWorx storage/database folder, and then remove the contents of the folder. Restore the contents of your backup to the database folder. An H2 backup only consists of two files. You've got your data.h2 and data.trace.db file. Much like restoring a Neo4j database, you'll want to rename your log files so that you get clean logs on startup. Finally, once all that's done, you can start the Tomcat server and check for errors. The PostgreSQL database provides a hot backup option. However, it's not enabled by default. The most common solution for a hot backup strategy on PostgreSQL is to enable write-ahead logging and wall file archiving on the database. Write-ahead logs are a record of all the transactions that PostgreSQL generates, which track all the operations that were performed against the database. When using a known good backup and the write-ahead logs that were generated since the full backup that was taken, it is possible to recover to any point in time between the time the full backup was taken and the time the last write-ahead log file was generated. This is known as point-in-time recovery. In order to configure PostgreSQL for hot backup, you'll want to create a folder for your backup files. This is going to contain your archived logs and your full backups. You'll want to know what your PostgreSQL data directory path is. You'll want to update your configuration files to enable wall archiving and to add the PostgreSQL user to a replication role. Once this is done, you can restart the PostgreSQL server, and now PostgreSQL should now be generating write-ahead logs in the pgdata/pgxlog directory. Every file name will be a long string of digits sequentially generated, and as the files roll over, completed files are copied over to the archived logs folder. There's a lot of steps involved in this process, and the full configuration details can be found in the KCS article 253933. Once you have PostgreSQL configured for wall archiving, the process to take a backup is this. As a Postgres user, you're going to want to run pg-based backup to create a full backup. The above command performs the following tasks. It copies and tars all the files in the PostgreSQL data folder, and then it copies the wall logs that were generated during the backup process. The xlog flag is required to ensure that the resulting backup is consistent without additional log files being tacked onto it. The pg-based backup command will create a snapshot on the database, at which point it will copy and tar all the files in the PostgreSQL data folder. Then it will copy the write-ahead logs that were generated during the backup process. This xlog flag is required to ensure that the resulting backup is consistent without requiring additional write-ahead log files. Once a full backup has been taken, the write-ahead logs that are older than the backup are no longer necessary and can be deleted to free up disk space. However, it's always a good practice to keep 2 or 3 previous backups and the corresponding wall files in the event that a recent backup is corrupt. You can always use the write-ahead log in addition with an older backup to restore your database to a point in time after that corrupt backup. When you're restoring a PostgreSQL backup, you'll want to try to make a full backup of the PG data folder, just in case you may need to go back for whatever reason. You'll want to ensure that you reinstall the exact same version of PostgreSQL if you're recovering from a hardware failure. Because you will have to restore all of the write-ahead logging configuration on a new installation, it's a good idea to have a backup of your configuration files available to speed that process along. Then you extract the tar files to their respective locations. You're going to extract base.tar to the PG data folder, and you're going to extract the file name with a number to the ThingWorx PostgreSQL storage folder. Once that's done, you copy the archived write-ahead log files back to the configured archive location, and you ensure that the PG data folder tree, the archive folder tree, and the ThingWorx PostgreSQL storage folder are all owned by the correct user, which is Postgres in most cases. Once all the files have been restored, you can then create a file named recovery.conf owned by the Postgres user in PG data that defines the restore command. The restore command is the opposite action from the archive command that was configured when you were setting up the write-ahead logging. The example in KCS article 253933 uses a simple copy command to copy WAL files to an archive folder. The corresponding recovery command would then be a copy that copies the archived WAL files from the archive folder back into the data directory. If you want to restore to a specific point in time, such as if somebody dropped a table that shouldn't have been dropped, you can set the recovery target time parameter to do a point in time recovery to a time that is earlier than the end of the backup set. Once you've got those files in place, you can start the PostgreSQL server to start the recovery. When the PostgreSQL server is done with the recovery, it will rename the recovery conf file to recovery done, and at that point the recovery is complete. Any errors with recovery are logged to the syslog. Once you've corrected the source of the error, starting the PostgreSQL server again will resume the recovery. Thank you for joining me today for this expert session on backup strategies.